Welcome to javaisawesome, and in this DSA series we are going to learn the basic mathematics, and this basic mathematics will help you to understand the advanced concept. Okay, so if you understood those 7 questions what I'm going to tell you right now, these are very important, and once you understand this you can build up your knowledge like doing logical questions, and slowly you can go with the DSA and we can understood in the better way. Okay, so let's start now. The first question is, if you are talking about the basic mathematics here, so the first question is count digits. Count digit means what? For example, we have some number. So what is the number? Number is a something which is combined of digit. Okay, so for example, if I say 1 is what, so 1 is a one number, 2 is what, 2 is a one number, 16 is what, it's a number, 123 is what, it's a number. Okay, but if I talk about digit, 1 is one digit, 2 is one digit, so 1, 6, 1, 2, 3, those are the digit. Okay, so combination of digit is called a number, correct? So for example, our problem is like we have some numbers n equal to 1, 2, 3, and we have to find out in this number how many digits are available. So for example, if you see here, there are 3 digits, 1, 2, 3. This is the 3 digits. If I talk about n equal to 4, 5, 6, 7, how many digits are there? So 4 digits. If I talk about n equal to 1, 2, how many digits are there? So obviously 2 digits. If I say about n equal to 2, how many digits are there? So 1 digit. So our requirement is someone will give you the numbers and we have to find out how many digits are available inside it. How you can do it? Simple question. How you can do it? Do you have any idea about it? How we can find out? Yes, we can do it. It's very simple. So you have to use some basic mathematics knowledge. I hope you know about it. So for example, if you have a n equal to, for example, 17. Okay, so n equal to 17, and if you divide this n with 10, what it will give? It will give obviously 1.7. Why 1.7? Because if you divide 17 with 10, if you divide 17 with 10, it will give 1.7, right? So 1.7, if you talk about in Java, so if I try to store this value in integer, so it will not store this value exactly. Okay, it will store only 1. Okay, right? And again what I will do is, I have a 1, so 1 I will divide with 10. What it will give? This is the 1 divided by 10. It will give 0, 0.1. Okay, so in our Java it will store as a 0 only. After that, if it is 0, I can't divide with. If I divide again, it will go infinity. What it will do? Infinite. Okay, so we don't want to divide again. Okay, so how many times I have to perform the operation to go up to 0? So this is the 2 times operations I have performed. 2 times operations, it means in this particular numbers having a 2 digit. So every time just you have to divide the numbers and you can get the actual numbers which you want. Okay, correct? Let's suppose we have another numbers. Let's suppose we have another numbers called n equal to 4, 5, 6, 7, right? And we have to find out how many digits are there. So what we can do? We can simply divide with 10. It will remove the last digit. Simply, if I tell you simply, it will remove the last digit and it will give 4, 5, 6. 7 is removed. Again, if I divide 4, 5, 6 with 10, it will remove the last digit, so it will give 45. If I divide 4, 5 with 10, it will give 4. If I divide 4 with 10, it will give 0. So how many operations I have to perform to go up to 0? 1, 2, 3, 4. So we have performed the 4 operations here to go up to 0, right? So we can simply say that we have a 4 digit in this number, correct? Let's do it and try to understand. So I'm going to my Eclipse, and if you see this Eclipse, in this Eclipse what I'm going to do is, for example, I will create one method here, okay, and this method responsibility is to find out, okay, how many digits are there inside this number. So this method will take one numbers and it will return one number, which is called a number of. We can open it, and then after, what we have to do, we have to do the operations and we have to return it back. So simply what we can do is, we have a one numbers, and in this numbers, how many digits are available, we have to find out. So what we can do, we can simply create one variable which is called count, and count will assign with the 0, simply, right? And then after we can write one while or for, whatever, but prefer to the while only, because we have to take only one condition, which is I, or maybe whatever the numbers we have. So number until not equal to 0, we have to do the divide. Once it is 0, don't divide it, I'm saying. So number not equal to 0, you have to divide it. So what I'm doing here, I'm just giving number equal to number divided by 10, correct? And after that, once it is divide, count equal to, I will give count plus 1, simply, correct? And after that, once it is finished, I will return it back, count, right? This is the methods we have to write. Let me maximize it so that you can understand in a better way. No, I don't want. Okay, so this is the digit count method. So we have created, and we have taken one value which is n, and here we have created one extra variable which is count equal to 0, and we are iterating the loop. This is the very important condition. So many people are confused why we have written n not equal to 0. So what we are doing, the initially n is not 0. N is what? N is something value, something numbers. So what we are doing, we are checking n not equal to 0. So it will go inside this while loop. We can divide with the 10. We can count 1. Okay. If it is 0, it will go again. And if it is 0, n is 0, it will make it 0 not equal to 0. It will become false, and we can come outside. So it will happen here, basically. Okay, and count equal to count plus 1, we are incrementing each and every times. Okay, so it will support it. Okay, so basically, and after that, once it is finished, we are dividing every time, and we are counting also, and once it is done, we can return it. So here we can call simply s out. Okay, and in the s out, we can print this value simply. So s out and digit count, I will call this methods, and here I will pass, for example, 17. So it will give, and also let me print some message, right? Digit number. So what is the number? Number is nothing but 17. So we can tick here int n equal to 117, and here you can pass the n. Here also I can print it, n number digit is, okay, whatever they will return with this method, it will print it here. So once I run it, you can see 70 number digit is 2. If I run again, it will give the same output. But if I change here, if I give something big numbers, okay, and if I ask how many digits are there, so if you see here 1 2 3 3 4 5, okay, this much digits, so 6 digits are there inside this number, if you see here, right? So like that we can do it. Okay, basically let me copy this code, and we can do with the online compiler also. So I have an online compiler, so let's go to the digit count. Okay, this is the in the Coding Ninja, you can go and you can check it out. I will give the link in the video descriptions. Let's see these codes. So whatever we have understood with the counter digits, with the same problems we can do here also, but something difference is the problem statement is saying we are the given numbers, which is n, so they have given one numbers n, okay, and find the numbers of the digits of n that evenly divided n. So find the numbers of digits of n. For example, if you have a n digit, let me go to here. For example, we have a one digit, okay, so we have a one digit called n equal to 135. So we have to check how many digits are there which is going to divide this n. So if I divide 135 with 1, it will divide. We have to divide with 135 with 3, 135 with 5, and if the remainder is 0, then we have to take those count, otherwise no. Okay, so if you divide 135 with 1, it will not give remainder 1. If you divide 135 with the 3, okay, so if you divide with 1 3, so 4 3 is 12, right, and 4 3 is 12, it will come and it will give 1, so 5 3 is okay, 15. So we can divide it, but still remainder is not should be 0, okay, we have to take care. So if you go to this story, okay, this problem, so if you see some example, for example, we have a 336. So 336 is divisible by both 3 and 6, since 3 occurs twice and it is occurred. Okay, so 3 is 2 times, so we can divide with the 3, so this is the 2 and this is the 1 time, so the numbers of the divisible will be 3, so we have printed the 3 output. If you see some other example, 35, so if you divide 35 with 3, what will happen? It will not divide properly, the remainder should be 5, it will happen. So if you divide with the 5 with 35, if you divide 35 with 5, what will happen? Remainder will become 0, so we can consider count as a 1. In the same way, we have to write a code here. So what we have done, we have taken one count, okay, so int count equal to 0, right, and here what we have to do is we have to add something we have to find out 1 and 1 element. So from extracting a element from any numbers, we have to find out as a modular. Okay, so let me take one more variables, int temp we can say, or you can say something other variables, or you can store your temporary element, which is n. Now what I am going to do is, this is the n, so my n is safe now, and I will do all those operation inside the temp. So I will take one while, WHILE, and while I will check temp not equal to 0, and from the temp is nothing but equal to n, so from the temp I will iterate one element, so I will take one element, so I can say like that also, otherwise direct I will write here also. So I will say int element or digit, we can say digit, and digit I can find out from the last with the help of the modulo division of 10. So whatever the temp I have, I will give the temp modulo division with 10, so it will give the last digit. I will explain you. Last digit, I will check if last digit, what are the digit we have, digit is not equal to 0, and whatever the digit I have iterated from the last, okay, whatever the digit I have iterated from the last which is also divisible for 10, so n modulo divisions I will give as a digit. If it divisible, and it will give as a 0, which is even numbers, you can say. So 0 means even numbers only. Okay, so what we can do, we can count it, count plus plus, COUNT, count plus plus, we can increment, and after that if it is not, then what we can do, we can go to the next digit, next digit, next digit. So here we can find out the next digit, and also I'm going to remove the last digit. So removing a last digit, I can take the help of the temp equal to temp divided by 10. I hope you understood, and at the end I will return count. Okay, so once I return the count, you can see the output, but I will explain you, no issue in that. Okay, so this is submitted, and let me submit it. It's submitted successfully. Let's go to here. Okay, and I explain you what exactly we have done. Okay, so for example, someone given n equal to 35, for example, and I have to understand this 35 is divisible with which digit. So what I can do, I have 35 with 3, 35 with 5. So if I divide with 3, it will give the remainder as a 5. It should not equal to 0, but if I divide here, the remainder should be, I can get what, 0. Okay, so here I will give the remainder as a 0. So because of that, we are counting 1. So here I will count it, but here I will not count it. Okay, so what basically we are doing, so I hope you understood. While finding a last element of the digit, okay, while finding a last element of the digit, so if I have a n equal to 35 and I want last digit, what I can do, I can write like that, temp equal to n modulo division 10. So if I write like that, temp equal to n modulo division 10, in the temp it will give me 5, which is the last digit. And again, next iterations, what I am doing, I am removing this element. I don't want this element. So what I have done, n equal to n divided by 10. So now L will store only 3. Correct? So for removing the last digit or getting the last digit, we can use these two things, which is very, very important. Okay? So modulo divisions, whenever you are taking the modulo divisions, it will give last digit of number. Okay, and if you are using just divided, it will remove last digit of number. So I hope you can focus on that, and this is really note down. It's a very important point, and without this you can't touch any mathematical questions, and it is very important. Okay, so I hope you understood how we are finding any numbers, any digit. Okay, if you divide, for example, let me explain some more. Okay, for example, we have some numbers n equal to 140. Okay, so these numbers I want the last digit. What I can do, I can just simply do that. I want last digit, so I will do any extra variables I can create, which is m in type m, and m equal to, I will give n modulo division 10. It will give the last digit. If I want to remove this last digit, what I can do, I can just do in that same way, n divided by 10. So what it will do, it will remove the last digit. If you want to remove two last digit, what I will do, I will divide it with the 100. If I want to remove the last three digit, I can divide with 3. Okay, right? So 3 digit I can remove, we divide with the 30, 1000. So this is the concept you have to understand basically. For example, I have a 10 equal to 17. I have given examples. If I divide with the 10, it will give what? 1, right? So it will divide with the 1, but we can get the 1, but remainder is 7. Okay, so if you do the modulo division, 17 by 10, it will give the remainder always. So be careful while doing this kind of the things. So extracting a digit from the any number, extracting or removing the any last digits of the numbers, it will help you to improve your coding also. But if you talk about the time complexity of this code is, so what basically we are doing, for example, we have a one number n equal to 1 2 3 4 5 6, something like it's a very big numbers we are able to see here. So this big numbers, if you calculate the time complexity, so we are sending this number here, and while sending, what we are doing, how many times this loop will iterate, it's depend on numbers of the operations or number of digit. So how many digits are there? If it is 6 digit, so time complexity is 6, right? So it will iterate 6 times only, and it will finish our work. Okay, so if I tell you what is the time complexity of this, okay, so while iterating a numbers, what we are doing, we are checking while number not equal to 0. So number not equal to 0, it will iterate if based on the digit. So it's a 6 digit or whatever the digit. So time complexity is, okay, so time complexity of this loop is, we can say very easily, order of n. But order of n where n is number of digit in number, where n is a number of digit where n is a number. Correct? Are you understood? So this is nothing but this is the number of digits are available on that numbers. That is called a time complexity is order of n, we can say. For solving these problems, we have used some space. So space complexity, if I talk about, So space complexity is order of 1 because we have taken one variables while solving these problems, which is count, and we have written it. So space complexity is order of 1 and time complexity is order of n, but where n is the number of digit in a number. Okay, clear. But some of the peoples, or maybe the some of the developers or interviewer will ask you, can you try to reduce the time complexity? Is it possible? Yes, it's possible, no issue in that. You can do it simply in the one line. Also you can do it simply. Okay, how? So you can just remove this code. Okay, how we can do is we can just remove this code, and whatever this integer numbers we have, so you can convert this number into the string. Okay, so integer dot to strings or integers dot we can convert easily. Okay, so whatever the numbers we have, we can convert it, and then after, otherwise you can do simply, you can concatenate also. So what you can do is you can create one string count variables, and inside the count variables you can just concatenate with the string integer plus string. So your n value will become strings, and then after here you can return length. Okay, so this will return the length of this count variable. So length is nothing but number of the characters, number of the digit, same thing. If you run this code, it will work. Okay, so this is also one way to do that. Okay, why it's giving some errors. Okay, so let me see the what is the error. So this is the 35. Okay, so here we are not doing those what we have, we are not exactly finding the length here. Okay, so let me remove those things. Okay, so while counting a digits we can do, it's a very easy, but here we have to count numbers of the times is available divided with that number, so we can't do that place. Okay, it will not take. But here while printing a number of the digits, so if you see here, this is printing the 6. If I run it, you can see. Okay, so let me run it. So what is this? It's printing, let me minimize it. So it's printing this number is digits, how much? 6. So here we can do those things. What we can do is we can create one extra variable, which is a string count, and here we can concatenate with a string. So integer plus a string will become strings, and it will become a string. So here we can find the length function. Okay, so length, and we can return it back. So it will also do the same thing what we are doing with the previously logic with the for while loop. So this will also do the same thing. If you remove any of the digit, it will print the correct output. Okay, what is the time complexity of this problem? So this time complexity is nothing. Okay, simple order of 1, order of 1 time complexity we can count it here. Okay, so if I talk about this, okay, this type of the issue, so here it's a very improvement we got. Okay, what we have done, so internally length function also count something, so we can say, but order of 1, and here also order of 1. Space complexity and time complexity both are order of 1. Okay, one more way we can do this issue. Okay, so if you want to find out, you don't want to find out like that, so what we can do is we can simply use logarithmic. We can use the help, we can take the help of the logs. Okay, So for example, we have a one math class, right? So math will give one function called, okay, one function called log base 10, and here we can pass our number, so it will return some fraction of it. So what we can do it, we can store it somewhere, okay. So while storing, we have to store inside the integer, so we can say count, and we are trying to convert it into the int because it will return the double value, and we can add one more value here, and finally we can return it back, return count. This will also give the same output, no issue in that. Let me run it. So if you see, the digit is 5. If you remove one more, it will say digit is 4. Okay, so like that you can do also. So this is the math.log base n. So it will find out what is the silly or floor value of this log base n. So this is the n, is how many digits are there, 1735. So it will give some approximate value, but we have removed the whatever the after dot we have, and we have added those value inside the one extra, and we have printed it. So like that also you can find out the those. Okay, what is the time complexity of this one? So if I talk about the time complexity of this one, so we are using the log, so we can say time complexity is order of log n base 10. This is the time complexity. And space complexity, if I talk about order of 0 or 1, you can say it's a constant value. So as much you can improve it. So what we have to do is we have to decrement the time complexity. Okay, decrement the time complexity. So if you are solving any problem with order of n, you have to decrement it order of 1. Okay, so always try the 3 possible way. One is brute force solution, second is optimal solution, and third one is better solution. So this is the 3 approach we have to follow: brute force approach, optimal approach, and better solution. So whenever interviewer will ask you any code, you have to first give the brute force. Once you give the brute force, then after you have to go to the optimal solutions, any improvement if it is possible. If it is not possible, go to the better solution. If better solution is also not possible, you can say this is the final approach for app I don't have any other approach. Okay, and we can do it like that. Okay, so I hope you understood. Thank you so much. So let's talk about the problem number 2, which is reversing a number. So now I'm going to take this one, reverse a number. We have understood the how to do the count the digits of any numbers. Now we can talk about how we can reverse the number. So if I give you a number n equal to 1, 2, 3, the output should be, you have to display like 3, 2, 1. If I give you n equal to something called -1, 2, 3, you have to display the output like -3, 2, 1. If I give you n equal to 120, you have to display, you don't want to display 0, just 2, 1 you can display, that is fine. Okay, so this is the things we have to do. So this is nothing but input and this is nothing but output. Okay, So this is the output, that is called a reverse number. So any numbers, if you want to reverse it, what you can do? Okay, so while reversing any numbers, what we can do is we can take one element from this. Okay, for example, I have n equal to 1 2 3. So first I have to take this element and I will store here in some other variables, right? Then I will take this element and I will store here. Then I will take this element and I will store here. Our work is done, right? So you can take here one string if you want to do in the simple way, but that is not a good. Sometime a string will not help you. Okay, so while fetching a data from the last, we already know, like whatever the n we have, you want to find out the remainders. Remainder means last digit. So we can write a remainder equal to whatever the n we have, modulo division with 10. So it will give the 3 first time. If you do remove the last digit, so while removing a last digit, what we can do, n equal to n divided by 10, not modulo division directly. So it will remove the last digit and it will give 12. Again we can find the 12 of remainder. So n modulo division 10, what it will give, it will give the 2. So first we can consider 3, then after 2, and then after 1. So like that it will give the data and we can do our operations. Okay, let's understand how we can do it. Okay, so I'm going to create here one method. So let's take these methods. Okay, and format it, and I will give the method name called reverse numbers. Okay, and it will take one number. So this is the numbers, for example, and we have to reverse these numbers. So number digit numbers reverse, I will write reverse each. And here what we have to do is simply, for example, someone given one number, so I have to check this number is even or odd. I don't want to check, I just have to check it's a negative or positive. So for example, if you want to reverse any numbers, so what we can do, we can iterate one while loop, and while loop will go up to I, whatever the n we have, n not equal to 0 or greater than 0. And what we can do is we can find the remainder. So while finding a remainders, we need one sum. So we can say reverse. Okay, and reverse will be 0 always starting. And what we can do here is, and at the last, once we find out, we can return the reverse numbers. Okay, and here we have to do some operations. So first we have to find the one last digit of any numbers. So for that I will create one integer called remainder. Remainder, it means last digit. You can say last digit. Last digit equal to whatever the n I have, modulo division with 10. So it will give the last digit. What I will do, I have a reverse, so I will do reverse. Okay, a reverse. Okay, a reverse multiply with 10 plus remainder. I will add not remainder, last digit. Okay, how it will work I will explain, no issue. Okay, and after that I will remove the last digit. So n divided by 10 I will give here. Okay, so how basically it will work. So here n having a 1 2 3, for example, here we have a 1 2 3. So it will go here n in 1 2 3. So n having a 1 2 3. Reverse is right now 0. Loop is just started because n is not equal to 0. It will provide the n modulo division 10. It will provide the last digit, which is 3. so we got the last digit inside these variables. What we are doing, reverse is already 0, so revert multiply 10. So any number multiply, we have to create the again some numbers. So what we are doing is, we are dividing with 10. In the same way we are generating some numbers with the 10. So whatever the reverse numbers we have, which is 0, multiply with the 10, so it will become 0, and plus last digit. So last digit is what? 3. So here in the reverse we got 3. Correct? Next time, here again, n equal to n divided by 10. So if it is divide, now n having a only, and only what? Last digit will be removed. So n having right now, first time it's given 1 2 3, next time it's having only 1 2, right? 1 2, and after that n is not equal to 0, again it will come, again it will find the last digit. So what is the last digit? 2 now, so it will give the 2, and here reverse is what? 3. So 3 multiply 10, it will give 30, and 30 plus last digit, okay, 30 plus last digit is what? 2, so it will become 32. So we are formatting it. So while formatting only, we have to multiply with the 10, so that the increment will be happen with 10, okay. And again if you iterate here, it will go n equal to n divided by 10. So n is what? 12. 12 divided by 10, it will give what? 1. So once it is 1, what will happen? Now again 1 not equal to 0, it will come inside this loop. Is true, last digit will give. So 1 modulo division 10, it will give 1. So last digit 1, so they will add here. So now if you see 32 multiply 10, 32 multiply 10, it will become 320, and plus 1 we can add it, so it will become 321, okay. And after that if you divide it, it will give 0. So now n become 0, so n not equal to 0 here. So what it will do, it will go outside and we can return the reverse simply. So once you return the reverse, what will happen? It will print it, okay. So let me call here reverse method, okay, reverse number methods. And if I run this code, you can understood what is the output. So right now output 1 2 3 is 3 2 1, correct. Let me give some big numbers here, right, like that number if I give, and if I try to reverse it, you can see what is the output. So output is like it's given 3 2 1 4 3 2, it's correct, okay. But still it will not work properly, because if I give minus 1, if I give minus, it will not give the minus, okay. So it's giving the minus 3 2 1, okay, right. If I give something called minus 3 2 1, and if I give something called minus 5, let's see it's handling or not. So minus 3 to 5 it's giving, okay. But somehow if you work with some of the if you go and work with some of the online compiler, maybe it will not work properly. So in that situation you have to do some extra work on that, then only you can get it the proper answer, okay. So let's go to the lead code, and here we have a one reverse integers, and reverse integer is having a some given range, given sign bit integer is x, return x with the digit. Reverse, if reversing x counts the value to get outside of the sign 32-bit integer range, they return 0, okay. So here having some more conditions, but let it be. So if I give this and if I try to submit it, let's see what is the output they are giving. Okay, compile time error because there is no n. so we can make it x. Okay, x, and this should be also x. Now if you run this, maybe compile time error will not come. Okay, and n divided by 10 cannot find the symbol n. I have already changed this to x, why it's giving. Okay, let me run one more time. So your code is accepted. Okay, your code is accepted and it's running fine. Let me submit it. Once you try to submit it, let's see what will happen. So if let's see here, the test case is 1045, but your test case is only passed 1036. Some of the test case is not passing. Okay, so they have given some range, okay, which we have discussed here. Okay, if it will go above the range, what we have to do, we have to return the 0. So what we can do is, here we can write one if condition. If reverse is greater than integer dot max. So simply I will go here and I can write a code here. Hey, if reverse, whatever the reverse we have, if it is greater than, okay, if it is greater than max length, integer dot max value, then return 0. This is the simple conditions we have added. Okay, let's go to the online compilers and paste here our code. Okay, once you paste it, let's try to run. Okay, accepted. Let's try to submit it. Okay, but still they have given some issue, like based on the some big value. Okay, so this is the range, x equal to it, that much. So let me give reverse is equal to also. Okay, so if it is reverse is greater than equal to this much, okay, but this one is not accepting. So what we can do, the reverse value we have to make long. Okay, now I will check it will accept or not. Okay, return reverse is okay, so in that place we can convert it to the int while sending. Okay, accepted. Let's try to submit it. So in that situation, if you see, if they are giving some minus value, in that situation it's not working properly. So if they have given some minus, so we have to handle the minus also, but in our case it's not handling the minus value also. Okay, because if this is the minus, then it will go and it will not work properly. So what we can do is simply, let's go here, and what we can do is we can take one extra variables here. For example, boolean is negative, and we can take if it is negative is, I will make it by default false, but if I check it, if it is false, so what will I do, if whatever the x I have less than 0, then it's a negative value. So what I will do is I will write two things. I will make it is negative equal to true, and also I will make it x equal to minus x, so that it will become a positive value. And while sending here, okay, while sending here, so I will check if is negative, if is negative is true, then send reverse value. If it is not, then send the positive value with minus. Is negative, then here minus. If not negative, send the positive value. Okay, let's try to submit it, like it's working properly or not, we can see. Okay, so again they have given some error. Okay, at the end I have put it reverse, and if reverse is greater than equal to, why it's not working, what is the issue? To give here equal to, okay, so equal to we can remove here, sending a 0, that is fine, reverse number, that is also fine. And here if you use in the while like x not equal to 0, sometimes it will not work, so you can use x greater than 0. Okay, it will work properly. So once I run it, you can see here it will be accepted, and once I try to submit it, speed up, it's accepted. So you can see here it's accepted now. Okay, and now let's talk about what is the time complexity and what is the space complexity for that. So if you see here, we are using one while loop. Okay, and for solving these problems we have taken one variable which is reverse, and other variable is boolean. Okay, only two variables we have taken. So anyhow we can say that, okay, for solving any reverse number, okay, while doing a reverse number, the time complexity we can say order of n, but where n is what, number of digit. Okay, number of digit in number, whatever the numbers we have taken, based on that it will calculate order of n. And time complexity, this is on. And what is the space complexity? So space complexity is order of 1 only, because it's a constant. Okay, so we can say order of 1, order of 2, and it's a constant time complexity it will take. And if you try to reverse this number, so we can reverse in some different way also. If you want to improve the time complexity or space complexity, you can do one things, like whatever the n equal to someone given 1, 2, 3. Okay, what you can do is you can create one string. Okay, and strings having a one method called reverse. Okay, so with the help of the reverse also you can reverse it, but first you have to convert it into the string. So integer to string, and string you can reverse it, and again from the string to integer you can do it, and you can get the output. Okay, so this is the one way also you can do, but that is the enough to do that reverse number. Okay, thank you so much. About the problem number 3, which is palindrome numbers, not Armstrong number. So problem number 3 is check palindrome numbers. So what is the palindrome number? Basically a number which is forward or reverse directions. If you pronounce or if you iterate, both are same. For example, I have a one number like 1. So if I read from the forward direction, yeah, backward direction, it will be same 1 I can say. If I have some number called 1, 2, and if I try to pronounce is 2 1, that is not same, so that is not a palindrome number. Okay, if I say 7, so 7 is nothing but 7 only, so it's a palindrome number, right? If I talk about something called 1 double 3 1, and if I pronounce it like opposite directions, I will write 1 3 3 1, so it's the same number only, so it's called a palindrome numbers. If the number is 1 2 3, and if I write like 3 2 1, both are not same, not palindrome numbers. Okay, so palindrome means if you reverse the number and exactly if the number is same, that is called a palindrome numbers. For example, here if you see 1 3 3 1, if I reverse it 1 1 3 3 1, so exactly I am getting the same number, that is called a palindrome numbers. So after doing a reverse of any numbers, if it is we are getting the same number, that is called a palindrome number. Okay, let's start and write a code for that. It's a very easy, just you have to know about the reverse function. Okay, so let me go to the Eclipse and let me write one class. Okay, so simply I can write one class and I will give the class name called anything, for example palindrome number, palindrome number. And what can I do is I can take those numbers and I will reverse it, and after the reverse I can compare with my original numbers with that numbers which is given reverse. If it is both are same, I can say that is the palindrome numbers. So what I'm going to do is I'm going to write one main methods, and inside the main methods I will call my reverse function. Okay, but before going to do anything, let's write one function called reverse. So public, it will return integer type value, and reverse. Okay, I hope you know the previous video, so based on that you can do it, but let me write it int number. Okay, so it will take one numbers and it will return one numbers. What I'm going to do here is I'm going to write a logic. Hey, while hey, while what, while number is greater than 1, right, or greater than 0 or not equal to 0, greater than 0, what you have to do is you have to do the reverse. Okay, so let me create one variable which is int reverse equal to 0. Okay, and while doing a reverse, what I'm going to do is I will take those numbers and I will store it here. So in the reverse having a 0, correct, no issue. So what I will do is I have a 0 and this number is a 0, so I will find the first remainders. Okay, so finding a remainder of any numbers, we can do numbers modulo divisor 10, so it will give the remainder basically. Okay, and after the remainder, those remainders I have to store it. You can do the concatenate or you can multiply also, so multiplication is also good, right? So for example, let me make it simple, so I will write here int remainders. So I got one remainder which is last digit. What I'm going to do is I'm going to write reverse, which is my variables, and I will do like reverse equal to reverse multiply with the 10 because I have to form again those value, and plus I will give here remainder. So this is the one way to do it, otherwise you can directly do that. Okay, and after that you can remove those last numbers. Okay, how can you remove it? You can write n equal to n divided by 10, so it will remove the last numbers after that, and finally here you can return it reverse numbers. Okay, I hope already know about it, so that's why I'm writing like quickly. Okay, and once it is reverse, what I'm going to do is here I'm going to take those numbers. So I have a one numbers int n equal to, for example, 1 2 3, correct, and I will store this number in some of other variable. So I can say int dummy variable I have created, and I will store the n value, correct. Otherwise not required also to do that. Okay, I can directly call this reverse function. Okay, but make sure it should be a static, so no need to create an object for that. Okay, static, and here I will call the reverse, and reverse I will pass in, it will return one reverse number. I will store those value here, reverse, and after that I can write one if condition. Hey, if reverse is equal to my actual numbers, say number is palindrome, number is palindrome simply. If it is not, you can say number is not palindrome. So for that I can write one else conditions, and inside this I can put number is not palindrome number simply. And if I try to run it, you can see here, let me run on the Java applications, and if I run it, you can see the output. Okay, number is not a palindrome because it's a 1 2 3, and if I reverse it, 3 2 1 it will become. If I give 1 3 3 1, so it's a palindrome numbers, and if you check it, okay, it's a number is a palindrome. So that was simple is it. Just what you have to do is you have to understand this logic, and this logic I have already explained. Okay, so I hope you know about it. What I am doing is I am going to do the reverse. So while reversing any numbers, we have to first the last digit. First we have to pick the last digit, which is remainders, and modulo 10 it will give the last digit, and then after those last digit we are going the, like we are adding from the last, and also we are formatting it to the 2 digit 3 digit like that. After that you can remove the last digit and you can do the operations. So let's talk about the problem number 4, which is Armstrong number, and that is also very popular. So many interview this question will be asked. Okay, so let's start now. The people having some confusion in the Armstrong number is like how we can calculate the Armstrong number. So basically some people are saying like any numbers you can do the Q and you can find out, but not like that. The thing is like whatever the numbers you have, for example, if you have a n equal to 3, okay, so what you have to do is, how many digits are there? Only 1. So you have to do the 3 to the power 1, and what is the calculation is 3. So 3 is what? Armstrong number. Okay, if someone given n equal to 1 2, correct? So what you have to do, how many digits are there? 2 digit. So what you have to do, 1 to the power 2 plus 2 to the power 2. What is the calculation? 2 to the 4, 4 plus 1 5. If this 5 is equal to the given number, then it's a Armstrong, otherwise it's not a Armstrong numbers, like that. 3 is equal to 3, so I have said right, okay, it's a Armstrong numbers. Like that you have to calculate. If it is 3 digit 1 5 3, for example, this is the Armstrong number. So what you have to do, how many digits? 3. So 1 Q plus 5 Q plus 3 Q. If you calculate it, 1 plus 5 5 ja 25, 25 multiply 5, how much? 125. So 125 plus 3 3 ja 9, 9 3 ja 27. Okay, if you calculate it, it will become 7 4 7 5 12, 12 plus 1, how much? 12 plus 1, so 13. So you can take 3. After that 2 2 4 4 or 1 5 and 1 15. So it's given exactly the same number which is our original numbers. So you can say this is the Armstrong numbers, correct? If you talk about 4 digit 1 2 3 4, same thing we have to do. 1 to the power 4 plus 2 to the power 4 plus 3 to the power 4 plus 4 to the power 4. Calculate it. If it is equal to that numbers, then Armstrong, otherwise no. That's it. I will give you some list of the Armstrong numbers. You can see here. So 1 to 10 digits are the 1 to 9 digits are Armstrong numbers. Then after it will go to the 153, 372, and it will go up to 3 digit, and then it will go to the 4 digit, and it will go to the 5 digit. So this is the flow we have. Those are the Armstrong numbers, you can say. Let's go and do the code for that. Okay, so quickly what you have to know about is how to find out how many digits are there in particular number. Okay, so let me go and create one class. Class name I will give Armstrong number, Armstrong. Anything we can give, Armstrong number. This is the class name I have taken. You can take anything. Okay, write the main methods, and then after you can calculate like it's a Armstrong numbers or not. So it will return true or false like that. So we can write public statics. Our return type is boolean. So you can write boolean and give the Armstrong number and you have to take one number. So you can say int n and take those numbers. What you have to do is you have to write logic here, but before going to write logic, what you have to do here, you have to send one number. So int n equal to, for example, 153 I have taken as examples, and I will check if while calling these methods Armstrong numbers, and I will pass my n. If it is gives yes, then I will say okay, this number is what? Armstrong numbers. It's Armstrong number. Some spelling mistake, but don't focus on that. Okay, let's go to the else case, and here you can write it's not Armstrong numbers. Okay, simple. If you go and write implementing of logic, so what you have to do, first you have to calculate what is the count of particular numbers. It's a 3 digit, or it's a 4 digit, or it's a 1 digit. Okay, simply. So what we can do for that, you can take one variable which is count, will be 0. Okay, and then after you can write one while loop. Okay, and if number greater than greater than 0, iterate it, count increment it, count plus plus, and just divide the numbers, which is n divisor equal to what? So it will remove the last digit. So through that we can achieve it, but we have to store somewhere our actual number. So what we can do is we can say int copy n equal to n. So this is the copy of n we have. Okay, and we know how many counts are there. While iterating it, we can understood what is the count. So count maybe the 2 or 3, whatever. So through that we can get the count. Then after every numbers you have to do the queue. Okay, so for that I need one more variable to store it, int sum equal to 0. Okay, and with the help of the math.pow function we can use it. So here I will write sum equal to sum plus and math.pow I can pass my numbers, but for that also we have to iterate the loop. Okay, and whatever the numbers we got, which is remainders, and here we can send the count, right? But these lines we have to put inside this loop only, we can do separately. So again we can iterate one while loop, and we can say right now our value is something, it's become something 0, okay, because it's dividing. So what we can do is we have a copy of numbers, okay. Again we can put n equal to, so exact value we can get here also, and then after what we can do is whatever the n we have which is greater than 0, find out one remainder in remainder last digit and do the q. So what we can do is we can do the number modulo division 10, it will give one last digit, do the pow. So doing pow we can use this function, okay, but here we have to typecast it to the integers, so it's become an integer now. And once it is done, what we can do, our sum will store here, okay. And after that also we have to remove the numbers from the last. So n modulo division, when divided by 10 you can do, so you can remove those number also. And finally what we can do is we can check here while doing a return, if if sum is equal to copy of number, if it is equal, return true, otherwise return false. Simple code. If you run this code you can understood, okay. So 153 is what Armstrong number, so it's saying stay Armstrong numbers. If you pass here 152 maybe, and if you execute it, it say it's not Armstrong numbers. If you pass here something called 9 or 5 whatever, which is single digit, right? It's saying it's Armstrong numbers. If you check some other also number, for example this is the one big numbers, 4 digit I have to take, problem number 5, and it's very important. Sometimes interviewer will ask you, can you write a code for the print all the divisors, and they will give one numbers, maybe 36. Okay, if someone give you a number like 36 and he told you can you print all those divider, so if you divide 36 with the 1, yes possible, with 2, yes possible, with 3, yes possible, okay, because 12 3 is 36, okay. So we can say 3 is also divisible. If you talk about 4 is divisible or not, okay. So if I talk about 4, so half of 36 is 18 and 18 half is 9, so it's not divisible with that, so we cannot consider it. If we talk about any 5, not divisible. If you talk about 6, yes divisible. If you talk about 7, not divisible. If you talk about 8, okay, 8, so not divisible. 9, yes, and if it is 9 then it will divisible by 18 also, and 36 itself also. So this is the possible dividers we can say. So what we can do is we can iterate one loop. Let's talk about the brute force solution, okay. Brute force means simple solutions, and what is the things like genuinely we are thinking first time, not logically, so we can say brute force. Okay, so brute force, it means like we have some numbers, so we can iterate the loop from 1 to 36, and we can check which number is going to divide by 36. If it is divided with I to 36, those we can print it. Simple, okay. So let's go and write a code for that. It's a very simple, just iterate the loop from I equal to 1 to 36. We are given number. Let me create one class, control N, you can click and write a class name. So search here class, and after that we can give class name like divisor or divider, anything. And once you created a class, what you have to do is you have to just write one main methods. Okay, I hope I have already explained more, so I don't want to do that. Okay, and here what you have to do is exactly, if I tell you, you can create one class or methods and just write like it's a what is the divisor. So we can write on methods, and I don't want to return anything, I have to print inside the method itself. So void I can give, and divide, dividers I can write here, and I can take one numbers from the user, so which is not a string, it's a int numbers I have to take. Okay, so I have to take in one int value. What I have to do now, iterate one loop. What loop? For loop. Inside the for loop you have to take one variable int I equal to 1. Why not 0? Not required. Okay, I less than equal to n, given whatever the numbers they have given, and I plus plus. Every time it will increase by 1, and I will check if condition, if n is modulo division of I equal to 0, it means it's divided completely. So what can I do? I can just print it. Okay, and while printing it, I don't want next line, in the same line I have to print it. So I can give my I and plus some space I will give simply. In the main methods I will take one numbers int n equal to 36 whatever, or you can call this method. So make sure your method will be a static so that you can easily access it. You don't want to create an object for that. Okay, so let me write divider. Okay, and I will pass my n, that's it. While calling a method, it will go inside this, it will iterate one by one from n times, it means 36 times, and it will check if number is equal to 0 after dividing. It means you have to print it. If I run this code, you can see the output. Okay, so let me run it. So this is the output, 1 2 3 4. Why 4? Is it 4 is divided? 6 9 12. Yes, if it is 12 is divided, then 4 is also divided. Okay, and 86, yeah, correct. So if you divide with the 436, what will happen? 4 1 point, so it will go to the 2 and if I say 3 to 5, okay, so carry is what? 2 and 3, 36, so 8. Yeah, we can say it's divided. So this is the output you can see, and you can expect it also. 36 up to 36 it will give, it will not give more than that. Let me explain here. Yeah, so this is the output. Okay, so this is the one way to print the dividers, or what are the numbers are capable to divide those numbers. So divided numbers I have printed it, it's fine. Okay, but if we talk about this code, so we can say it's taking the like time complexity is order of n square, order of n. Okay, if you see the code, you can see directly you have to iterate from 1 to n this loop. So because of that, the time complexity is order of n. And what is the space complexity? We are not taking any extra variable, so it's a constant time. So we can easily say that, okay, time complexity is order of n, because we are iterating one loop, or space complexity we can say order of 1, because we are not taking any extra variables, so constant one variables we have taken, so order of n, that's it. Okay, but in the brute force, can we able to minimize the time complexity? Because space complexity we are not taking, but time complexity, can we have any way to minimize it? Because it's taking order of n time complexity. So if I say time complexity, it's taking order of n. Can we reduce it? Okay, so if I talk about 36 is a numbers, and I want to reduce the time complexity, so what we can think is, okay, if I am dividing the 36 with 1, so 1 itself is a divisor, okay, and 36 also a divisor, so both we can print it. If you divided the 2, so 2 and what is the half of this? If you do the half is 18, so 18 is also part of that. If I talk about 3, so 3 and 12 also. Okay, so what we can do is, we can think like we can iterate one loop of the root. So we can find out 36 root is 6, we can say. So we can iterate one loop and it will go up to 6 only, because based on the root we have to check, okay, how many times we can iterate it, and it will go up to 6, and after that it will go to the reverse. So what we can do is, for example, we have a 36, right? So 36 we can divide by 1, okay, and after that we can check, okay, what is the half of 36? So 36 is 18, so 18 by 2, what is the half? 18 by 2, and after that what is the half? So 12 by 3, okay, what is the half? So if you talk about the half of the 12 is 6 by 4, we can't say. 12 by 4 we can say. So 6 by 4, so 6 by 6 we can say. So this is the 6 by 6. So what we are doing is, we are considering here 9 also. So if you consider here 9, okay, 9 by 4, so it will give the 36, 9 by 4, and after 9 you can go to the 6, so 6 will not divided with the 5, okay, so only 6 we can consider it, okay. Code for that. So what we can do is, this is the brute force, so what we can do is, in the brute force only we can not iterate the entire loop, we can go up to root. So here I can find out the square root, okay, so we can use here math library and math dot square root, okay, and we can pass our n numbers, okay. Once you pass it, let me format it, so it will go up to n. If you want to convert it, you can convert into the int noisome, okay, and I plus plus, and here what we have to do is, n modulo division equal to I equal to 0, then print it noisome. But after that, if n is not equal to n by I, if not equal to n by I, then what you have to do? N by I, then you can print this also. Okay, why I am writing this, like sometimes if you see the 6 is not a itself, okay, so itself this pointing, so for that we can ignore it. So this is the n, which is number, and this is the n by I, which is the value, and here I can print my n by 2. Okay, and I can give some space here so that it will maintain it. Okay, if I run this code, you can see 1. Okay, why next line? I don't want next line. Okay, if you see here 1, 2, 18 and 3, 18, 4, 18, 6. Oh my god, I don't want to print like that, but here if you see, if I is not equal to n by I, then we can print off n by I. Okay, itself only. So this will print the correct value 1, 36, 2, 18, 3, 12, 4, 9 or 6. This is the correct value, you have to print it. Okay. You see this, like we are going up to the math.sqrt. So we can consider the time complexity of this one is order of square root of n. Order of square root of n, because we are iterating the loop up to square root time only. So square root of n we can say, but in the previous like brute force approach we are iterating up to the n, so we can say order of n. Okay, so I hope you understood. Let's talk about the next question, which is check number is a prime or not. So that is also very important, and so many interview they asked check number is a prime or not. So what is the prime number? A number is only divisible by 1 and itself. That is called a prime number. It will not divide with any other numbers. That is called a prime numbers. If I talk about prime number, will start with the 2. So we can say 2 is divided by the 1 or itself. So 2 is a prime numbers. If I talk about 3, so 3 is also divided with the 1 and itself, so it's a prime numbers. If I talk about 4, so 4 is not a prime number because 4 is divided with the 4 itself, 1 or 2 also, so we can't consider it. 5, yes. 6, no. 7, yes. So like that you can say the numbers which is divisible by only 1 and itself, 1 and itself, 1 and itself, 1 and itself. That is called a prime numbers. It's a simple. Okay, let's talk about the brute force approach. So what you have to do is it's a simple. What you can do, you can write one loop which is going up to 1 to that given number, and it will check not n, we can start with the 2. Okay, and those numbers we can divide from like whatever the n numbers we have, so it will go from 2 to n up to, and it will check if it is divided. What we can say like this number is not a prime number. If it is not divided, then we can say it's a prime numbers. Okay, let's start. It's a very easy question. So what we can do is we can create one class, or in the same class we can do it. So here I'm going to create one methods. Okay, and it will return one boolean value. Okay, and let's make sure it should be a static. And here I will give like prime check, and it will take one number, so int n. Okay, so what we can do here is simply we can write one for loop, and we can tell hey for loop start with n equal to 2, so int n equal to 2, and go up to like not n, I have to consider it I, and I equal to 2, and I will go up to n, and I plus plus, not n because we don't want to consider the itself, so less than n you have to write. Okay, and here you have to check if in between I have skipped the 1 and I skipped the last one also. So in middle of that, whatever the numbers we have like to other numbers, if it is able to divide those numbers, then we can say this is not a prime number. So what we can do is, we have a numbers, so mode of divisions with the 2 we can do. So n modulo division 2 equal to 0. Okay, then return, directly we can return it, return true. It's a return true means it's a prime numbers, check prime. So return false, should be false. And otherwise, if it is iterated, not divided, so at the end we can return it true. It's a not prime number. Okay, it's a prime number, we can say it's a prime number. Okay, so this is the things I have written here. What we have to change here, so simply you have a one number, so what we can do is, you can call this method, but while calling this method you can check one condition, like if I not equal to not I, whatever the value we have, n not equal to 1, okay, and we can call our method prime check. If it is giving that true, okay, prime check if it is true, yes, is a prime number, then what can I say is, I can print it, it's prime number. If it is not, in the else case we can print not prime numbers. Okay, simply it's not a prime numbers. Okay, and if I run this code, you can see the output, what it's giving. So it's not a prime numbers. 36 is able to divide some other numbers also, so I can take something called 31. Okay, and I will divide it, it's a prime numbers. If I give only 1 also, okay, and if I check it, it's not a prime numbers. If I talk about 3, so 3 is divided itself and 1 only, so it's a prime numbers. If I talk about some other value, like some big numbers also, you can test it, like it's divisible or not, so you can test it, it's not a prime numbers. If I talk about 200, it's not a prime numbers. Okay, so like that you can test all those scenario and you can do the operations. Okay, but if you see this code, we are iterating the loop from 1 to n approximately, so the time complexity is order of n and space complexity is order of 1, which is constant space time. Okay, so how we can reduce the time complexity from order of n to some other? So what we can do is, we can do some modifications here, and we can think like, okay, if the number is divisible by itself only, so we can consider up to root, square root only. If it is divisible, then we can say directly it is a number is divisible by those, otherwise no. Okay, so we have started with that 2, and we can write math.sqrt, and we can pass our numbers up to that, give equal to here. Okay, if it is able to divide up to sqrt, so for example, I have given something number called 36 and it's able to divide it, so it will say correct, like okay, this is not a prime numbers. If you give something called 31, okay, and if you talk about this as square root, so it will find out some square root. Okay, and based on the square root, it will, for example, 5 square root, so 5 square root something, so it will give the integer value, and based on the integer it will iterate 1 to 5 and it will try to divide it. If it is divisible, then so you can say it's a prime number or it's a not prime number. So quickly you can decide with the help of math SQRT, and it's very helpful also, and you can say it's a prime numbers. Okay, if you want to test with the 5, you can test it. You can test it with 5, 7, whatever the numbers you are trying to test, you can test it's a prime numbers. Okay, so make sure whenever you are going with the divide, checking the prime numbers or something else, whenever you are talking with the divide, then think about the square root also. It will make your work very simple. Okay, and now if you talk about the time complexity, the time complexity is reduced order of square root n. Square root of n means what? Whatever the we have the numbers n, of that square root we have reduce it. So it's a very big things, and it will become a very fast also. If you run any compiler, it will work very fastly. Okay, let's go to the some other questions. Okay, and we can check about it. Okay, 7 we can see it's also very important, and it's based on the Euclidean theorems, and Euclidean theorem is very important also. Some of the times it will help you very good way. What is the full form of GCD? GCD is matlab means greatest common divisors, and HCF I know you already know. Okay, so we have to find out the HCF of any number. So it is means like common, divisibles of the both the numbers. So for examples, what we can do is we have a two numbers, a equal to 4 and b equal to 8, and we have to find out which one is the biggest divisor of both the numbers. So it's a 4 only, because 4 can divide the a and 4 can divide the b also, which is 8. So let's do it. How we can do? So first we can find out what is the minimum numbers in both the numbers, and after that we can divide with that both the numbers, and if it is both are divided, we can say those are the answer. Okay, let's go and write a code for that. So simply I can create one class. Okay, and class name I will give GDC. Okay, class. And inside this I can write one main methods. Okay, I have base some numbers which is 1 and b. So int a equal to 4 I can give, and b equal to 8 I will give. So this is the two numbers I have. What I have to do is I have to find out what is the minimum number. So minimum numbers we can find out easily. So we can use one for loop. Okay, and it will start with the 1, right, and we can go up to minimum numbers. Okay, what is the minimum number is possible? So otherwise you can take any other numbers also, that is fine, but start with the 1, and here you can write math dot mean function we have, and we can pass two variable a comma b, and it will give the minimum numbers. Okay, go up to that, and here I plus plus, that is fine, and inside this you can write one if condition and check both are divided or not with that number. So we can do a modulo division with the I is equal to 0 or not, and b modulo division of I equal to 0 or not. If both are divided, take one variable which is answer and initially it's a 0, and here what we can do is you can just store those value in the answer, which is nothing but I. Okay, and finally after going to the after for loops, you can print it. Okay, GCD is, simply you can print it here. What is the answer, right? And let me show you. Okay, so if you see the GCD is 4, but this is the one way I told you. But if you want to do with the like the formula called equivalent, EUCLIDENT, equivalent theorem, so through that also you can do it. It's very also simple. The theorem, what it's saying is like, if A equal to B, then definitely B of A modulo division B is also same. This is the formula, and through that also you can find out it. It's very normal. Okay, so what we can do is we can just comment it. Okay, just comment, and after comment remove the comment here, and here you can call these methods. Okay, GCD, and we can pass here A comma B, and we can create one methods GCD, it's a fine. And I can mouse over on it. It will create one method for me. What I can do is, here I have to write some base conditions, and I will write base condition like, if B is equal to 0, then no need to do anything, just return A is the answer, right? Because if B is 0 and it's not divisibles, okay, any number, so you can say A is biggest. If not, what you can do, you can call the GCD again. It's a recursive function call, so you can call GCD, pass the B, and here you can pass A modulo division B. And if I do that, I don't want to do anything, and it will give me the correct answer. You can see I have not done anything, and it will give me the answer also. If I give here something called, this is 12 or 16, or here I can give something called 8, that time also it will give the biggest divisible numbers, which is 8. Correct? So this is the things you have to focus, guys, and it's very easy. Okay, please do the practice, then only you can get good enthusiasm on that and good intuition also in that. Okay, then only you can succeed in your life. Thank you so much.